so much. So, Luke, I'm very curious what you will tell us. Please go ahead.
Yes. Well, thank you very much for the nice introduction. Hello, everybody. I am Luke. I am currently a PhD candidate at the University of Amsterdam, together with the psych department there. And in a course in January, I used GPT-4o to provide preliminary grades and feedback to students. So this was actually using a model during an active course. And you will find a lot of similarities to what the speakers before me already told you, but I think there's also a little bit extra in there. This is actually the first project of my PhD, which I worked on together with my supervisors, and I also received some additional support from Sharoon and Saurabh. If you are curious into more of the details, I'm very happy to say that this paper that I wrote about it got accepted at the AI in Education conference this year. And I think the proceedings should be published in a month or two. Now, before sharing what I found and what I did, I want to share a core motivation with you, which is that I strongly believe that we should use large language models for grading as long as they are accurate, because it will give educators more time to actually educate. I think it is really a shame that teachers spend as much time grading, because when you grade students, you don't teach them anything. You don't improve them. So I think if it works, we should use it. Now, here's what we did. In January, my supervisor and I were teaching a programming course to research master psychology students. This was an introductory programming course lasting 4 weeks, and it had a pretty intensive workload. So there were a lot of lectures. There was real-time tutoring via Slack, so they could ask us questions all the time. And they also had to do 4 take-home assignments and 1 in-class exam. And as you can imagine, this is a lot of grading for the 2 other PhDs, myself and my supervisor. So my goal was to create an automated pipeline that would provide students with fast preliminary grades and feedback, which is something that we teachers do not have time for at all, unfortunately, in that course. The pipeline that I created is available on GitHub. So if you want to try implementing it for your own course, you can do so. And theoretically, it should work simply by adding a few of your own API keys and changing some IDs. As you can already see, what I did was integrate Canvas, which is a learning management system. So this is a system where we teachers can set up assignments and then students answer them and we grade them. And UvA Chat. And UvA Chat is an internal endpoint for prompting large language models set up by the Teaching and Learning Center at the University of Amsterdam. And this is super nice because this ensures that all of the data remains on university servers and none of it is used to train any proprietary models. So every week, we would ask students to work on their programming assignments, and we would then ask them to format their files using these question indicators, #R1, #Python3, and so forth. And we also asked them to validate their submissions using a Shiny app. Not everybody did that, more on that in a second, before uploading them to Canvas. Then after every assignment deadline, I would run this semi-automated pipeline. I say semi-automated because I had to manually run it from a Jupyter notebook. Theoretically, this could be a cron job that runs overnight, as long as all of the submission files are formatted properly, which they weren't. So every week, there were like a couple students where I had to go in there and fix some of that manual formatting, which took me 10 to 60 minutes. The first step of that pipeline is to automatically download all the submission files from a given Canvas course. So this is just based on IDs that you set in a settings file. And then all of these files are passed into JSON. And every entry in these JSON files corresponds to 1 question. And this was important so that we could then prompt the large language model to grade every single question for every single student individually. So this is a very similar approach to what we saw in the previous talks. And our reasoning behind this was that we wanted to see how accurate the model was actually at grading, not only the entire grade. And we also thought that this would probably improve the accuracy instead of dumping a whole bunch of tokens at once. What you can see on the left is a reduced version of the prompt. So this is not the real prompt, but everything important is in there. It included the task description for every question, the example solution or answer key, the student's answer, and rubrics. And then we also instructed the model to strictly grade according to the rubrics and award between 0 and 1 points. So these rubrics were subtractive, meaning there were multiple rubrics per question, saying stuff like subtract half a point if the student did not set their working directory correctly. And then what is also important is we instructed the LLM to format the response using these HTML tags. In my experience, this works a lot better than asking for more complex structured outputs across different models and different temperature settings. So this is a tip I can give you whenever you work with these models, regardless of grading. Then the final step of that pipeline is to calculate the final grade of every student based on the individual question-wise scores. These grades are automatically updated in Canvas. And additionally, a feedback PDF is compiled for every student. Because in addition to the grading prompts, we asked GPT-4o to feedback every single question. And the goal of that feedback was to provide students with helpful advice, regardless of whether they had that particular question right or wrong. So this sometimes also included coding style improvements. This PDF report is then also attached to the assignment in Canvas, so the student has access to it the next day. And we also added an automated comment saying something like, be mindful, this is a preliminary grade, don't worry about it. The teachers will still grade you. Please engage the PDF feedback. Now, before telling you what the students did and how accurate it was, let me share with you that LLM grading in this way is fast and cost effective. Thank you very much. So every week we graded 60 submissions. These included our own test submissions. And a human grader, this took us between 16 and 20 hours, depending on how long these assignments were. And the large language model, it only took 6 hours. And this could be cut down by a lot if the batch API would have been set up. That would have been much faster. Students had to wait up to 12 days to receive their grades from us humans because they were sick leave in one case. But they received the grades hours after the submission deadline, so literally the next morning. Grading cost about $500 US, depending on who graded and what their salary was. Prompting GPT-4o cost between $15 and $20 US, depending on the number of questions. And then finally, we humans could provide almost no individual feedback. Every now and then I would attach like a small comment if I wanted to give some particular advice to a student, but it was just not feasible. And the model would print out or compile a comprehensive PDF report. So how did students like this? They really appreciated receiving rapid feedback on their assignments. However, some of them were also a bit anxious because, as you can see in a second, the grades awarded by the model were oftentimes lower than the final grades that we humans gave them. So let's have a look at that. First, at the question level. What you can see here on the x-axis are the points awarded by the human to a particular question of a given student. So as you can see, there's 4 different steps possible. And then on the y-axis, you can see the same for GPT-4o. This is about between 6,000 and 7,000 questions. I'm not entirely sure about the right number. But what we can see is that in 80.5% of the cases, we have perfect agreement between GPT-4o and the human grader. But we also see that in 17% of the cases, humans awarded more points. And only in 2.5% of the cases, GPT-4o awarded more points. So this matches what the students told us, that they often received lower grades from the model than they would eventually receive from us humans. Now, there are different reasons for that, and I will get into them in a second, but let's first look at the level of final grades. What you can see here is 5 plots. On the x-axis, you see the human grade given to a student. So this is the actual grade they received for that assignment or the exam. And then on the y-axis, you can see The same for the model. And we see that we have positive correlations in all cases, but we see this very clear bias because most of the points lie below the dotted line, meaning that the humans gave a higher grade. And in some cases, this is pretty extreme. So for example, this student would have failed the exam. This student would have received a 7 from the human, which they did, and they would have probably failed the exam if the model failed. So you don't want to be that student. As I said before, there are a couple of reasons for finding these results. And what you can see also for assignment 2 is a very important clue. The correlation is a lot worse here. And the reason for that is assignment 2 pretty much only contained questions where students had to plot data. Okay. We did not provide GPT with any plots. We did not provide GPT with any code outputs. And that means that for some of those questions, particularly those where students used packages that created a plot using a single line of code, GPT-4o was unable to reliably judge whether all the important stuff was plot. It worked pretty well for standard stuff like ggplot, because then it could just see everything. But for these edge cases, it didn't work. And then also assignment 4, 20% of that grade depend on the number of lines of code a student wrote. And then based on a mathematical formula, they receive points. GPT-4o just completely hallucinated both the number of rows of code and the associated number of points. And I think that the conclusion for this is, for this particular point, if you want to use a large language model to grade your stuff, be very mindful with the types of questions you design and the types of rubrics you design. But there's also another side to this story. I went in and looked at a bunch of the disagreements between model and human. And I found that in about 30 to 40% of the cases of the disagreements, it was actually us who made a mistake. Very frequently, we human graders overlooked a mistake the student had made and gave them full points for code that wouldn't run.
Right.
A very clear example, the student assigned a variable lowercase, and then they called that variable uppercase later on in the code. It was probably still in their R environment when they were doing it. We didn't run the code for 60 students for all questions. Sometimes we just looked at it and we're like, ah, yeah, that's correct. Yeah. We missed those, GPT-4 didn't. So at least some of those grades that we gave the students probably should have been lower. Now, this is a very interesting comment, by the way. Yes, GPT-4o, the new models can also execute code and they can work with images. But at the time when we were doing this, all the internal settings for this particular endpoint that we were using did not allow it. But what did we do after the course? Well, we wanted to see how does GPT-4o compare to the exam grades if we use 4 humans to grade them, because as we already heard, oftentimes even humans disagree on grading exams. And what you see here on the y-axis is the final grade for a student in that exam. Every line is a student. And the range indicated by that vertical line means that at least one human grader awarded the low point and at least one grader awarded the high point. And the 4 graders are somewhere in there.
Were the students known by the teachers or was it
No,
anonymous?
So what we did was we graded students anonymously and we also graded them question-wise. So we would grade all assignments question 1, all assignments question 2 in a random order.
So the bias of, oh, I know this guy or this girl, probably that was not there.
I mean, after grading 400 questions, sometimes you spot patterns, of course, but it was the best we could.
Yeah, okay, perfect.
So what is really striking to me is only in 3 cases, the 4 of us, so I am one, my supervisor is one who graded the exam before, and then 2 research master students doing their research internships with us are the 2 others. And we only agreed perfectly in 3 cases. One of those was a 10, so I guess that student just did everything right, and then the 2 around the 8. And in quite a few cases, we have a really big range. So this one, for example, I think 2 of us gave a failing grade of 4 point something. One of us gave a barely succeeding grade of 5.6, and then one of us gave a 7.2.
The person needed some coffee, probably.
Maybe. And this really shows that even with these super clear rubrics, subtract X amount of points if, we have these disagreements with humans. But where does the model come into? Once I will click to the next slide, you will see points appear, and you will see blue points, which are all the cases where the model was within the range of the human grades, and you will see red points, which are all the cases where the model awarded a grade outside of that range. Any guesses how it will look like? We already heard a lot today that maybe large language models are nicer than humans. I have to say, we can't find that. So as you can see, most of the points actually lie outside of that range, and almost all of them lower.
So you missed a lot of mistakes.
Well, this was a regrading, so I hope there were fewer mistakes in there, especially if it's done by 4 humans. But it is true, one of our students still found cases where all 4 of us missed one of those typos in the code and the model didn't. So yes, there are still cases where all humans were wrong, but at least now we can be a lot surer that the real grade should be somewhere in that range.
Is that probably because as a teacher say, oh yeah, you're all okay, but you got the main part, so I'm not gonna subtract.
So maybe there are some teachers who have a positive bias. I have plots that I don't have in these slides where we can pretty clearly see that one of us has a very clear positive bias, another one has a slight positive bias. I personally apparently have a very negative bias. And then one of us is pretty equal. So yeah, there are these differences between humans as well. Leniency, I guess, in some cases. But what I wanted to share with you is there is also hope, because remember, this was based on these subtractive rubrics, and I can tell you they were a pain to grade as a human because they contained a lot of weird language, such as double negatives and a lot of text, like the subtract 0.5 points. It was really painful, and in retrospect, I don't know why we did it to ourselves. But a student of ours, Galigella, has been trying to use different prompting techniques, and what she used were positive rubrics. So instead of subtract points if the student did not do that,
All right, yeah.
just evaluate true or false if a student did something. And what you can see on the right is the result for the exam based on that. So up top, you see one of those positive rubrics. It's a lot simpler to process also for us humans. And a lot more of the grades are within the ranges. So that looks really good. We have to see if this is just completely overfit for the exam or if this also applies to the other assignments and other courses. But it's not that easy to get multiple graders to grade that many assignments.
Maybe it's easier to understand what is there instead of what is not there.
Yes,
Right.
Yeah, it's difficult.
It's just a general it's just a general indication for answer models in general
Yeah.
that you don't use subtract, but you reward students for what is. So it's always positive and not negative.
Exactly. And as I said, in retrospect, I don't know why we did it to ourselves.
Quite different.
In the future, we will use these rubrics. But on that note, I also want to point out a few other of our research master and behavioral data science graduate students. Some of those are finishing their theses. So if you're interested in contacting talented people, here are their email addresses.
Great.
And I also want to thank all of you for your attention and also the interesting questions in the chat. And let me know if you want to collaborate. As I said, it is super difficult to get a lot of teachers to grade the same assignment. And it would be amazing to do more research on exams from different courses different subjects. And I just started my PhD, so I'll be doing this for the next 4 years. So let me know.